Welcome to this explainer on the NCP-MCI 7.5 exam, specifically Objective 3.6, NIC Compatibility for RDMA. Look, if you're an infrastructure admin managing environments on the AOS 7.5 and AHV 11.0 baseline, this is a topic you literally cannot afford to skip. Objective 3.6 is notorious on the certification exam. Why? Because of its strict hardware dependencies and incredibly rigid configuration rules. Today, we're going to break all of that down. We'll cover exactly how remote direct memory access works, the underlying hardware requirements, the specific software drivers you need, and the exact deployment order of operations. By the end of this, you'll be fully prepared for both real-world deployments and, of course, your exam.
Here's a quick look at our agenda. We'll be covering why RDMA compatibility matters, SR-IOV and OFED essentials, foundation pass-through and examples, post-cluster RDMA LAN setup, common certification exam traps, and we'll finish up with the key facts to memorize.
Okay, Section 1, why RDMA compatibility matters, and the baseline of Stargate communication.
To start, we need to understand exactly what we're trying to achieve in a Nutanix cluster when we talk about RDMA. At its core, we're utilizing a protocol called RoCE. That stands for RDMA over Converged Ethernet. Now, in a standard setup, Nutanix Stargate services are constantly communicating with each other to manage storage across the cluster. Since Stargate handles all the storage I/O and data replication across the distributed storage fabric, it generates a massive amount of east-west traffic. RoCE is brilliant because it allows these services to communicate directly by accessing memory over the Ethernet network. It's a total game changer for latency because it completely unburdens the hypervisor by offloading all that packet processing. But, and this is a big but, this powerful performance leap heavily depends on absolute rigid strictness regarding your physical NIC compatibility.
This comparison really hits the nail on the head as to the why. Think about standard VM networking. Every single packet processing rule goes through the hypervisor, right? That consumes valuable CPU cycles that, frankly, could be running your actual workloads instead. By using SR-IOV NIC pass-through, we're giving a virtual machine, in our case the controller VM, direct access to a dedicated physical NIC port. We are intentionally ripping the hypervisor right out of the data path to drastically improve storage performance. And that leads us perfectly into the specific hardware stack you need to make this all happen.
Section 2, SR-IOV and OFED essentials, the hardware and software dependency.
You simply cannot run RDMA without a specific hardware capability known as SR-IOV, or Single Root Input-Output Virtualization. And listen, this isn't just some clever software trick or configuration setting. This is a physical specification baked right into the PCIe NIC hardware itself. It completely removes the old-school limitation of needing one physical port per VM. Instead, SR-IOV allows a many-to-one mapping. This lets multiple virtual machines access a single physical NIC port directly. It's literally the physical foundation of our RDMA setup, ensuring the CVM gets the dedicated, low-latency access it needs without monopolizing the entire network card.
But having the hardware alone won't get you there. You also absolutely need the OFED driver. That's the Open Fabric's enterprise distribution. Think of OFED as the crucial software bridge. It's a package containing the kernel modules and user space libraries that the operating system needs to actually talk to that SR-IOV-enabled NIC. Now, if you only remember one thing from this section for your exam, let it be the RDMA NIC Compatibility Matrix. Your OFED driver stack must strictly, and I mean strictly, match the physical NIC's firmware. It has to be validated against the specific SR-IOV hardware version via that official matrix. If there's a mismatch, the whole stack just fails to initialize. No way around it.
Moving right along to Section 3, foundation pass-through and examples, deploying the Mellanox stack. Let's look at how this builds during the actual cluster imaging phase with foundation. It happens in a very specific sequence. First up, baseline hardware validation. Every single node must have 2 factory-installed RDMA-enabled network cards. Next, during the imaging process, Foundation steps in and reserves the entire NIC, configuring the necessary ports for RDMA and ISR. And finally, we get the CVM pass-through. The CVM receives a virtual NIC named exactly RDMA 0, mapped directly to the first RDMA-enabled physical port. The crucial takeaway here for your timeline is this. Because this reservation happens right at the start during Foundation, the host hypervisor is completely locked out. It cannot use those reserved ports for any other standard VM traffic.
Now let's talk about the actual card, specifically the Mellanox family. The generation of card you use directly dictates your cluster's features. Nutanix supports pass-through during foundation with cards like the Mellanox CX-4, CX-5, CX-6, and CX-7. But look at the stark differences here. If you're running an older CX-4, you do not get zero-touch RoCE or ZTR, and it actually blocks live port pass-through. You're basically stuck with just basic data replication over RDMA. On the flip side, modern cards like the CX-5, 6, and 7 fully support these advanced features, giving you robust networking without the headache of complex switch configs. So here's a massive point for the exam. You can mix different NICs across different nodes in a cluster, but the oldest family dictates the features for the entire cluster. It's the weakest link rule. If you have even a single node with a CX-4 card, it instantly disables ZTR and live port pass-through for every other node in the cluster.
Section 4. Post-cluster RDMA LAN setup. Moving to the logical layer.
Okay, once foundation is done and the hardware pass-through is set up, we enter the logical phase. And this is a huge order of operations concept. Foundation does not configure the actual RDMA LAN. Read that again. Foundation sets up the hardware and gives you the RDMA 0 interface, but you have to manually enable RDMA and configure the network segmentation after the cluster creation is entirely finished, and you do this via the Prism Web Console.
When you jump into Prism Element to set this up, here's what's actually happening. You're creating a separate, dedicated network on your existing default virtual switch. The system takes those RDMA 0 interfaces we talked about and places them onto this new network. You'll need to assign a dedicated non-routable subnet to it, which means carving out 2 IP addresses per node. Why non-routable? Well, this is pure back-end, east-west storage traffic. It should absolutely never route out to your core network. Keeping it isolated is critical for preventing latency spikes and maintaining security. Plus, while it might be optional in some basic ZTR setups, Nutanix highly recommends slapping a separate VLAN ID on this traffic for true switch-level segmentation.
Section 5. Common Certification Exam Traps. What not to do. Let's dig into the edge cases the exam loves to test.
All right, trap number 1. Remember how we said you can mix NICs across different nodes in a cluster, even if it drops you to the lowest common denominator? Well, you can mix across the cluster, but you absolutely cannot mix on the same physical node. If you take a CX-4 and a CX-5 and put them in the exact same chassis, or even if you mix speeds, like putting a 10 gigabit and a 25 gigabit CX-5 card in the same server, RDMA is permanently broken. The system instantly detects the mismatch, and it will flat out refuse to let you enable RDMA on the cluster.
Trap number 2 is all about installation. You're going to see scenario questions where a field engineer drives out to a site to install RoCE cards into an existing non-RDMA block to give it a performance boost. Do not fall for it. RDMA-enabled cards must be installed at the factory. You cannot add them to a node in the field and get a supported configuration. Why? Because field installs completely bypass the rigorous factory validation and firmware baselining that these highly sensitive pass-through configurations absolutely depend on to function.
And trap number 3 revolves around cluster expansion. Let's say you're adding a new node to a cluster that already has RDMA turned on. The system is smart. It auto-provisions RDMA for the new node. But it's also stubborn. It automatically selects the first available port based strictly on the lower PCI bus ID. The trap here is that you cannot intervene. You cannot change that RDMA port selection during the expansion wizard. If your data center cabling requires you to use a different port, the workaround is pretty brutal. You literally have to disable RDMA for the entire cluster first, make your modifications, and then rebuild the configuration.
Section 6. Key facts to memorize. The architect's cheat sheet. Before you go sit for your exam, make sure these 4 rules are locked in your brain. First, RoCE depends on physical hardware SR-IOV and a strictly compatible software OFED driver validated by the matrix. Second, know the division of labor. Foundation handles the hardware pass-through to create the RDMA 0 interface, but Prism Element is where you actually configure the logical RDMA LAN. Third, while you can mix NICs across a cluster, you can never mix RDMA NIC families or speeds inside a single physical node. And fourth, if you mix families across the cluster, the oldest card writes the rules. A single CX-4 node kills zero-touch RoCE for the whole entire cluster. I'm going to leave you with this mock exam question to test what we just covered. If you add a new node to an RDMA-enabled cluster, can you change the RDMA port during the expansion process? Think about it for a second. The answer is firmly no. You have to disable the cluster-wide RDMA configuration first before making any port changes. So, knowing how incredibly strict this hardware layer is, does it change how you're going to plan your next infrastructure rollout? I hope this explainer has you feeling fully confident to crush Objective 3.6 on your NCP-MCI exam. Keep studying and stay curious.